Greetings, mathematicians. In this video, we're going to be looking at another type of factoring, specifically how to factor trinomials. But first, we'll start with a quick review. So go ahead and pause the video and try to factor these two problems, and then come back to check your work. All right, so now that you've had a chance to try these two, the first question had just a GCF of 4xy. So you divide the 32, the negative 60, and the 8 all by 4. You get 8, negative 15, and 2. And then the variable parts, they all had at least one x and they all had at least one y. So that also came out as part of our GCF. The second one was actually a two-step problem because it had a GCF of 72. And then once you factored that out, you were left with 4y squared minus 1. But 4y squared minus 1 was a difference of squares. And you could factor that into 2y plus 1 times 2y minus 1. So now we're ready to move on to another kind of factoring. So far we know to check for a GCF first, then look for a difference of squares next. Now, a third kind of factoring is we're looking for trinomials. So we're looking for something that looks like ax squared plus bx plus c. And we're going to look at how do we factor something that looks like that. So first, you'll see here's an example of something that is of this form. So ax squared plus bx plus 6. An example of that would be 1x squared plus 5x plus 6, where the a would be the 1, the b would be the 5, and the c would be the 6. And what we would do in order to factor this is we would do a method called factor by grouping. And the steps to this would be that the first thing we would do is we would find factors of AC. And what that means is a times c. So for the problem that we see up there, a times c would be 1 times 6, which is 6. So we'd find all the factors of 6. So it could be 1 times 6 or 2 times 3. Those are our factors of 6. And they have to have a sum of b, and our b is 5. So that means they have to add up to 5. Well, 1 times 6, that has a sum of 7. And 2 times 3, that has a sum of 5. So it's these two numbers that we want. We don't want the 1 and the 6 because they have a sum of 7. We do want the 2 and the 3 because they have a sum of 5. So now we're done with step 1. We want the 2 and the 3. Now in step 2, we want to rewrite the b terms. We want to rewrite the middle term in terms of these two factors. So instead of a 5x, we want to write a 2x and a 3x. So we would rewrite 1x squared plus 5x plus 6. We would rewrite that as 1x squared plus 2x plus 3x plus 6. Now, you might be wondering, would it be okay to rewrite this as 1x squared plus 3x plus 2x plus 6? Like if instead of rewriting this up here as 2 times 3, you rewrote it as 3 times 2? That would be okay. You're going to end up with the same answer in the end either way. Now step 3, you're going to split this expression into two groups of two terms. So what you'll do here is you'll put parentheses around the first two terms and parentheses around the second two terms. That's step 3. Step 4, you're going to factor out a GCF from each group. So you're going to think of it as like two mini problems. So 1x squared plus 2x, that's a mini problem. Find the GCF. So 1x squared and 2x, that has a GCF of x. And when I factor out the x, I'm left with this. And then, copy this plus sign, the 3x plus 6, that has a GCF of 3. And when I factor out the 3, I'm left with an x plus 2. So previously you learned how to factor out GCFs. You basically just kind of do that 2 times. Now, if you have done step 4 correctly, you will always, every single time, end up with the parts in the parentheses being the same. If you have not done this correctly, they will be different. So this is kind of a place where you can check your work. And in step 5, you're going to factor out that common binomial. So since they both have the x plus 2 that's the same, and you're factoring that out, then you'll be left with this x and this plus 3. And that goes in a second set of parentheses. So that should be our answer, the quantity x plus 2 times the quantity x plus 3. And then step 6 is to check our work by multiplying that out and seeing if we get that original problem. So you can do the distribution method, or you can do the area model, whichever you like to check your work. So I chose to do an area model, putting the x plus 2 on one side of the box, the x plus 3 on the other side, multiplied everything out, and I do get the same thing as my original. So let's try a couple more. So for our next problem, x squared plus 5x plus 4, the a is 1, the b is 5, the c is 4. So a times c is 4, b is 5, and I'm trying to find things that multiply to ac or multiply to 4. That's 1 and 4 and 2 and 2, and we want to know which of those add up to 5. Well, that's 1 and 4. Those add up to 5, 2 and 2, that adds up to 4. So now I'm going to replace the middle term with the 1 and the 4. So I rewrite that as x squared plus 5x plus 4. And then I group the first two items together and the second two items, and now I treat this as two mini GCF problems. So x squared plus x, that has a GCF of x, and 4x plus 4, that has a GCF of 4. If I've done this correctly, I have a common binomial, and then what I have left is the value that goes in my other set of parentheses, and I can check my work by multiplying these out, and I should get this original problem. Now I'll go through and try this next one. Be a little careful here because now we have some values with different signs. So here my a is 1, my b is negative 6, my c is negative 7. So my ac is 1 times negative 7, which is negative 7. My b is negative 6. So now I need to think of things that multiply to negative 7. Well, it's either 1 and negative 7 or negative 1 and positive 7. And which of those add up to negative 6? Well, that is the 1 and the negative 7. So now I'm going to rewrite the problem where I rewrite the negative 6x as a 1x and a negative 7x. Then I use grouping, and I factor out GCFs. Don't forget, for this second set of terms, if the leading coefficient is negative, you must factor out a negative. So negative 7x and negative 7 are both negative, so I have to take out a negative x, or a negative 7 rather. If I've done this correctly, I have a common binomial, which I do. They both have an x plus 1. And when I factor that out, I'm left with an x minus 7. Again, I could check my work by distributing that, and I would get this same original trinomial. All right, so here's my next one. A is 1, B is 13, C is 40. So AC is 40 and B is 13. I need to think of everything I can think of that multiplies to 40. So 1 times 40, 2 times 20, 4 times 10, 5 times 8. And I want to figure out which of those add up to 13. Well, that is the 5 and the 8 add up to 13. So I'm going to rewrite my problem, and I'm going to replace the 13x with a 5x and an 8x. Then I use grouping by putting the first two terms together and the second two terms together. I factor out the GCF from the first set of parentheses and the GCF from the second set of parentheses. If I've done that correctly, I've got a common binomial. In this case, it's x plus 5. And then whatever's left over, the x plus 8, goes in the second set of parentheses. If I were to distribute that to check my work, I would get that original value there. Okay. Last problem, my a is a 1, my b is a negative 18, my C is a 32. That means A times C is 32 and B is negative 18. So I start thinking of things that multiply to 32, like 1 times 32 or 2 times 16. And I'm looking for something that adds up to 18, or actually negative 18. Now, if I think here, they have to multiply to a positive, but they have to add up to a negative. So think about that a little bit. If they multiply to a positive, they have to have the same sign, a positive number times a positive number, or a negative number times a negative number. So actually, these are going to have to be negative. And then that means that these are actually the values that I want. So negative 2 times negative 16 is positive 32. And negative 2 plus negative 16, that adds up to negative 18. So those are going to be my values that I'm going to replace my negative 18x for. And then I'll do my grouping. And now I'm going to be looking for my GCFs. Okay, they have a common binomial of x minus 2. And then I have an x and a minus 16 left over. All right, last up before we stop for this video, give these problems a try, factor them, and then come back to check your work. All right, and here are your solutions for you to compare your answers with, and that is where we will stop for this video. So thanks for joining us, and we'll see you next time. Bye for now.